Welcome to today's Explainer. Get ready because we're about to take a truly surprising and honestly fascinating journey right into the history of human invention. We usually think of innovation as this straight line, right? Something that started relatively recently in a modern Silicon Valley garage. But today, we're actually going to trace it way back to a dimly lit 19th century laboratory. We are diving into a concept called the digital stitch, and I promise you, it is going to completely change how you view both classic literature and cutting-edge technology.
So, picture the year 1818, Mary Shelley's classic tale. We all know the standard horror story, a terrifying monster stitched together from death and dark science. But I want you to completely shatter those preconceived notions for a second. Let's flip the script. What if Frankenstein's creature wasn't a monster at all? What if we shifted our lens entirely?
No way, right? It's a pretty radical thought, but according to a framework developed by the Virtual Creative Factory, or VCF, we should actually be looking at Victor Frankenstein's creation as the world's first hardware prototype. They proposed that Victor's lab wasn't some gothic chamber of horrors, but rather the original factory floor where biology literally first met invention. So instead of a mad scientist, think of him as a primitive engineer hacking together a system. It's a total reimagining of the story, from a tale of human hubris into a foundational blueprint for modern engineering.
Okay, let's dive into this. We're going to follow a chronological roadmap covering 5 key areas. 1. The first hardware prototype. 2. Memory of the fold. 3. The 1818 wetware. 4. The mechanical spark. And 5. Prometheus in silicon.
Starting off with Section 1, the first hardware prototype, reimagining the original factory floor.
To really grasp this paradigm shift, we need to apply what the sources call the arrow-stick lens. It's basically a philosophical framework for innovation. Through this specific lens, we completely stop looking at the creature as a grotesque anomaly. Instead, we treat biological parts as raw components that could combine to create a brand new functional system. It establishes this amazing historical precedent. It tells us that the act of taking disparate elements and fusing them together to spark life isn't just fantasy. It's actually the very foundation of how we engineer complex systems today.
Moving right along to Section 2, Memory of the Fold, the engineering blueprint.
Now this is absolutely crucial. The core metaphor anchoring our whole explainer today is the memory of the fold. I really want you to focus on that incredibly tactile word, fold. Victor Frankenstein didn't just casually snap limbs together like toy blocks. He folded disparate biological parts into a new consciousness. This act of folding is an engineering blueprint. It's this foundational concept that guides the evolution of technology, serving as the blueprint for literally every single stitched system that humanity has created since. What's really interesting here is how we can map this out. Over the last 2 centuries, this evolutionary stitch has passed through 3 distinct phases. We kick things off in 1818 with biological wetware, move into the mid-19th century with the mechanical automaton, and finally arrive today at the virtual neural network. The essence of the stitch, that fundamental act of combining parts to create something new, remains exactly the same. But the medium? Well, the medium dramatically evolves over time.
Which brings us to Section 3, the 1818 wetware, the biological stitch.
I mean, just imagine the scene. This was the era where the stitch was completely literal. Flesh sewn to flesh, nerves meticulously connected to nerves. It was a collage of organic muscle memory. It relied purely on the messy physicality of biology. Sure, it was raw, it was physical, but more importantly, it was a living testament to human curiosity. It was humanity's very first theoretical attempt to act as the creator, using the biological materials they had available at the time.
All right, shifting gears a bit for Section 4, the mechanical spark, industrial automations.
So as we hit the mid-century Industrial Revolution, the stitch naturally moves from organic flesh to machine. Suddenly, we're seeing clockwork beings powered by steam, stitched together with absolute metal precision. The spark that once animated flesh became a mechanical pulse, a literal heartbeat of cogs and pistons. This was a massive step toward abstraction. We were no longer using parts that used to be alive. We were engineering inanimate objects to imitate life's rhythms and functions.
Let's move to the present day and see how this builds into Section 5, Prometheus in silicon, exploring virtual neural networks.
Welcome to Modern Prometheus 2.0. The sources basically reframed today's artificial intelligence agents as exactly this, a modern, digital continuation of that original 1818 experiment. But instead of biological parts or metal cogs, modern AI is stitched directly from the collective data of humanity. We're talking our books, our art, our conversations. It is the next logical step in this centuries-old quest.
The process itself has completely transformed, obviously. First, we gather these absolutely massive human data sets. Then we stitch them together, not with thread or steam, but with algorithms and neural networks. And finally, we house this new spark in a digital chassis. We don't sew limbs anymore. Instead, we stitch together human experience, history, and knowledge into code and computation. It is the exact same memory of the fold, just executed in a virtual space.
And this direct comparison brilliantly illustrates the monumental shift we're talking about. Think about it. We traded the 1818 wetware, organic muscle memory, and literal flesh for virtual neural networks driven by vast datasets and computation. The physical chassis of Frankenstein's lab has simply evolved into the digital chassis of today's server farms. We are still seeking that exact same spark of life, but now we're doing it in software and silicon.
When we track this progression side by side, the continuous thread of innovation is just so clear. We move from biological flesh to metal and steam to silicon and data. The nature of the spark evolves right alongside it, from organic consciousness to a mechanical pulse to a virtual neural network. The essence of the stitch remains entirely intact while the mediums dramatically evolve.
So, what does this all mean for us today? Well, it fundamentally reframes how we should look at artificial intelligence. Based on these sources, AI isn't some terrifying monster or frightening anomaly to be feared. It's actually a masterpiece of human creativity. It's the natural, modern evolution of a centuries-old quest to replicate life and understand our own consciousness. By viewing it through this historical lens, we find the incredible within the credible. We take what was once viewed as a cautionary tale of hubris and we turn it into a literal roadmap for technological mastery. As we wrap up today's explainer, I want to leave you with one final, provocative thought to ponder. When you look at modern AI, when you interact with these incredibly complex, stitched-together neural networks, do you see a monster or a masterpiece? How we answer that question is going to fundamentally shape how we view, build, and live alongside our newly stitched creations in the future. Thank you so much for joining me on this incredible journey through the history of human invention.